Alright, here's example 7 with evaluating trig with inverse trig. So we're going to do this like we've been doing by using this flowchart here. But there is going to be something a little bit different here that we want to point out just to make sure of something. But anyway, let's go ahead and start using the flowchart. And if you want to copy this flowchart to follow along with, check the video description. There's a link in there. You can click that link, open this up, print it out, and follow along. Okay, so inverse cosine of the cosine of negative pi over 4. So we start at the top. Is there a domain violation? No, because we can take the cosine of anything we want. That's totally fine. And if we take the cosine of negative pi over 4, we're going to get something that's okay to put inside of the inverse cosine. Totally fine. So no domain violation. Is the function paired with its own inverse? Yes. Inverse cosine and inverse cosine is paired with inverse cosine. So yes, the function is paired with its own inverse. Is it possible to cancel? Well, let's see. So what was the rule for canceling with cosine? It was inverse cosine of x equals x if 0 is less than or equal to x is less than or equal to pi. Okay. But notice negative pi over 4 is actually not between 0 and pi. So this is actually not going to be equal to negative pi over 4, so we cannot cancel like that. That's not okay, not going to happen. Okay. So no, we cannot cancel. Now, I do want to point out that there is something that we actually can do to make it okay to cancel, but let's skip that for now and then we'll come back to that. So is it possible to cancel? No. Can the problem be solved using the unit circle? In other words, is this some nice number from the unit circle? Yeah, negative pi over 4, right? That's one of the, well, pi over 4 anyway is one of the nice angles on the unit circle, so negative pi over 4 is also a nice angle. And we can use the unit circle to solve this problem. So we can evaluate cosine of negative pi over 4 using the unit circle, and then we can evaluate the inverse cosine of that. So yes, can the problem be solved using a unit circle? Yes, so do it. Okay. So we can do that, we can go ahead and do it that way, or before we even started this problem, what we could do is look at this and say, oh, let's use even odd properties. So remember, cosine is an even function, so cosine of negative theta equals cosine of theta for all real theta, right? So in particular, cosine of negative pi over 4 equals cosine of pi over 4. Okay. So we can actually use that to simplify this problem from the beginning. So inverse cosine of cosine of negative pi over 4 is the inverse cosine of the cosine of just plain old pi over 4. Because cosine of negative pi over 4 is cosine of pi over 4, and the reason for that is that cosine is an even function. So remember, we talked about this a long time ago, way back in an earlier video. Cosine is an even function, which means cosine of negative theta is cosine of theta for all real theta. So specifically, cosine of negative pi over 4 is cosine of positive pi over 4. Therefore, cosine inverse of cosine of negative pi over 4 is cosine inverse of cosine of positive pi over 4. Okay? Now, we can just start the flowchart with this problem. So, is there a domain violation? No. Is the function paired with its own inverse? Yes, cosine, cosine inverse. Is it possible to cancel? Well, yes, actually now it is, because pi over 4 is between 0 and pi. Okay, so pi over 4 is between 0 and pi, so right away we can just say, okay, cosine inverse of cosine of pi over 4, we can just cancel and just automatically say pi over 4. And that's our answer. Okay. So the point here was that before you start in a trig with inverse trig problem like this, try to simplify it as much as you can using the even odd properties and also using periodic properties if you can. So we didn't use periodic properties here, but we could have. If, for example, let's say that were 9 pi over 4 instead of negative pi over 4. If that were 9 pi over 4, then we could simplify using periodic properties and we'd actually get the same answer. But yeah, so the point is, before you start this flowchart, try to simplify with even odd properties and periodic properties, and it might make the process simpler. So we can still do it by not recognizing that. Okay, but the path we would have followed was we would have started here. No domain violation. Go here. Is the function paired with its own inverse? Yes. Can we cancel? No. Can we use the unit circle? Yes. So we could have done that. But since we recognize that cosine is an even function and we use that even function property, then the path we followed was no domain violation, yes, paired with its own inverse, yes, we can cancel. And canceling is definitely easier than using the unit circle. Not that this would have been difficult, but it's just more to think about, more work to do, and canceling is easier. We definitely would prefer to cancel if we can. So that's why it's good to remember these even odd properties and remember the periodic properties, and definitely use them if we can. So that's the point here with example 7. So that's one more example of evaluating trig with inverse trig. More coming up in the next few videos.